Hello students, Ms. Slyman back again with a graph of another rational. So like I said in the last video, we care about our key points. Here our key point is going to be x equals -1. I'm not allowed to equal -1. So that's going to make an asymptote. Let me put that in as with green. Here's my x equals -1. And again, what I care about, I'm going to look at what happens when x goes to -infinity, x goes to +infinity, and as x gets closer to -1 from the left side and closer to -1 from the right side. So let's look at it systematically. As x goes towards -infinity, so I'm going to think about what's happening as I put in really big negative numbers. So if we did -100, we'd have -104 divide by -99. So that's like 1, very close to 1, and very positive. At 1,000, -1004 divide by -999. Again, even closer to 1 and positive, but always bigger than 1. So this is making me think that I have another asymptote at +1. And I'm getting closer to it on the positive side so that means I'm coming in from above, approaching it this way. Well, that leads me to think I'm probably going up towards +infinity, and let's see what happens as x approaches -1 from the left. So as x goes towards -1 from the left, so that would be like letting x equal -1.1. So let's see what happens there. I'm going to come back and use my calculator. So -1.1 minus 4 divide by -1.1 plus 1 is -0.1. And I end up with 51. So 51 is super positive, and up here somewhere, well, way up there. So that tells me that my assumption was correct and that I'm getting closer and closer to +infinity as I go up. And we don't really need to worry about key points. We want to worry about our shape. We could try -2. So if x is -2, so at -1.1 we got 51. At -2, we would get -6 divided by -1, so +6. So I actually go through this point here to -2, 6 is a point. But again, we don't really care about seeing points, we care more about the shape. So we really care about the asymptotes and the shape. Now rational graphs, I suspect based on what we saw in example 1, that my next side is going to be down here, but let's verify it by thinking about what's happening. So as x goes towards -1 from the right, well, let's start with far to the right. That would be x equals 0. We would get -4 divided by 1 is -4. So I assume that my next value is going to be very low down here. Let's try -0.9, because that's very close to -1. So I'm going to come up. So -0.9. And now if I think about it, this top number is always going to be negative, because any negative number minus 4 is going to stay negative. But now I'm picking numbers to the right of -1, so -0.9 plus 1 is going to be +0.1, and that's going to be true. I'm always going to have a positive, so I'm always going to have negative divided by positive, which will always be negative. And sure enough, I get -49. So way down here. So I'm coming up. I'm of course never going to touch this x equals -1 because I can't divide by 0. but dividing by 0 makes infinity. So either positive infinity or negative infinity. Here it's positive because I have negative divided by negative. Here it's negative because I have a negative number divided by a positive number. Once I hit 4, so 4 is another key point, because when I plug in 4, I get 0 divided by 5, which is 0. And after 4, any number bigger is going to be positive. So let's take 10. So now we're looking at x going towards positive infinity. So at x equals 10, we end up with 10 minus 4 is 6, divide by 11. That's just bigger than a half. When x equals 100, I have 96, divide by 101. This is close to 1, but less than. So my assumption looks like it's going to hold true, that I'm going to get closer and closer to positive 1, never actually reach it. And I'm never going to reach positive 1 because to reach positive 1, those two things would have to be equal. But x minus 4 never equals x plus 1. So a lot of these rational graphs we're applying thought to and trying to figure out what it's going to look like. So what I'd like you to do is to go through and complete examples. So I want you to try example 3, and I'll come back and show you example 4. So you try example 3 on your own. Make sure you go back and check your answers.